Alright, should be live-ish. So this is another draftphysics.com, debatephysics.com, also video presentation. So just going to see where my conversation goes, just kind of making the argument that physics, could have been a simple science instead of the convoluted, mushy, wooey, kind of religious thing they turned it into. And completely, without any real hard reasoning or incentive or purpose, or nothing demanded them to go to the wooey space. They just voluntarily went there. And it's just kind of a glaring example of the failure of, I would argue, of the atheist kind of cold, clinical, brutal capacity to look at ourselves and our function and the context of the universe as what it is, a system that just evolves, and it's just made out of some, elemental functions, and the functions just produce, over time can produce complexity, and but it's a mindless, mechanism, and it obeys those kind of rules of evolution, in that it's simpler at its basic function. The rules of the chemistry are simpler than the chemistry becomes, as we obviously demonstrate. So it's just kind of disappointing that science is just kind of it kind of went to it kind of got to a point where it was being realistic about what can be stated about existence, and then just kind of just return the road back to religion, back to just making up some sort of phony narrative of magic and purpose, and trying to contrive it out of just even the thing of where they call it a free will if they create a random will. So if you don't know 2 + 2 = 4, and instead you say 3 or 17 or 94, simply because of some random mistake, well, that they would call a free will, when it's not a sensible will, it's not a smarter will, it's not a reasonable will, it's a shit will, garbage, junk, chaos will. And yet they'll think they have advanced the ball. Somehow that's a better description, or a better place to be, is in a condition where you have the capacity to make gigantic errors. Little distractions. So I guess, all right, so the little stuff there is basically just kind of pointing out that I could argue that the descriptions of ether, I would argue would have to be in some kind of form where you could understand that, yes, you have two objects in space and there's a way that they can communicate with each other, but you don't need the geometry of an ether. You just need the fact that there's stuff that can move. The idea that it's all dominoes, that you hit the domino and somehow it bounces back up, and then it's ready to be hit again, or to communicate pressure back and forth. Those are things that can sort of make sense, I suppose, to us, because we can build such a thing. But why would it make sense for the universe to be, in that condition? I don't think there's any reason to think it's all dominoes, because then you have to compress them and crush them into more higher density substances, and a lot of that just loses any connection to something you could say that was a realistic thing to have happen. All right, so this all goes back to, you could say, Descartes and Newton started Galileo, of course, the conversation about how things basically communicate, and the fact is that somehow they're doing that. That's sort of what gravity's demonstrating, is in a real sense, objects are aware of each other's presence, and that there's some mechanism through which they're communicating their presence. But they already knew that, because there were stars that we could look at, and figure out the difference between a star and another planet. And then, it was a big step for them just to get the sun where it's supposed to be, in the center, and the planets orbiting, and then the solar system, and the idea that the stars that we see are just other suns, very far away. And there's every appearance. What the hell is that? There's always something going on here that shouldn't be. Computers. All right. I don't know why that opened. Anyway, I don't have nowhere to put this stupid mouse. That's the problem. Okay, my problem, of course, but my problems become your problems when you're watching my videos, right? So anyway, so Descartes, I liked so much of what he said in terms of being the first one that really got the conversation, yes, the ability to conserve conversation. Yeah, it still sounds like conversation. Yeah, it still doesn't sound like the right word. Anyway, the fact that you have to conserve motion in the universe, and the idea that anything that happens is the event happens in this object, but this object leaks the event. It just keeps leaking and going somewhere else. And so there's the stuff called energy is really, you could understand it has to be in some sort of discrete form, and that you can clump it into something big, but it's really made out of something very small, because it can be so easily converted into something very small. And for him it was ether, and the idea that you could swirl stuff in this ether, this substance, and cause things to be affected because you're swirling the water that the other thing is in, and it's going to cause it to move. And so it wasn't very good, but it's also, they didn't have a very clear understanding of exactly how planets did orbit and all that stuff, so you can understand making some mistakes, especially before Newton made it so clear, how gravity was just like the sun's producing photons, like a light bulb producing sun, like a candle flame producing light. It's just that in reverse. The inverse square law is the same concept. And so all you have to do is figure out that, well, if you were in a world where there was a bunch of candles all around you, all those photons would be hitting you, and in a sense, they're concentrated where your location is, in the sense that they're all pointed right for you, all the ones that'll hit you, obviously. And it's going to create the same thing if you could actually create a light source, that was equal from all distances, all locations. It would have the same effect as being just the opposite of the light coming out is the light going in, or the pressure. And, it would perfectly duplicate the inverse square law, and you'd end up with this compressing force, in the universe, that there's a high pressure in the universe. So the simple Newtonian, Newton didn't speculate on the, what was causing gravity, but certainly in his time they did talk about the idea of particle gravity. Lesage is what it's called, but it was really Fadio who first stated the idea of understanding that you could make the inverse square law out of particles in a pressurized universe, in a universe where particles already have motion. They inevitably would push things together because they would shadow each other from force, and therefore there'd be less pressure between them and more pressure outside of any two objects, and they'd be pushed into each other. So it does provide a simplistic description for gravity. Now, so, it's I don't know why, Newton didn't feel comfortable saying, well, that I could live with that, even though you still have to explain how things can move through that medium, okay, without being slowed down. So you do know that things orbit and move very fast around other objects, and somehow matter isn't slowed down going through that atmosphere of particles. So there's some mechanism that somehow negates the processing of that pressure. Somehow the pressure doesn't work when the object's moving through the pressure, but the pressure exists when the pressure is just being applied from the external universe. So there is reasons to say, okay, it won't work, it can't work. I'd say the positive, the fact that it duplicates gravity so well is a very good reason not to dismiss it without as no resort, as if you have, because you really should. You can't replace it with any other theory that works as well. There's not some other mechanism or some other way you can describe this except coming up with something like what Einstein just makes up, a fake mechanism. He just says there's a bent geodesic thing, all right, some mechanism that creates the inverse square law in terms of a pressure, and because it's not a real thing like real particles, he doesn't have to explain drag. So he escapes having to account for his theory because his theory doesn't have a mechanism. It's not mechanical, so it doesn't have to be defended for any side effects it has, because it can't have any side effects because it's a perfectly fake thing. So just like their dark matter, where they invent an idea of some kind of matter that doesn't react to photons, it doesn't react to any of the stuff we know of that things are going to reflect or be absorbing. And so they make up some invisible man that has special invisible man powers and call that physics. And I just argue that that should be a last resort, not a first resort. That shouldn't be something physics says is acceptable as an answer, because I could say that these particles are they have magic powers, okay, and so they don't cause drag because of the magic power. And that's no better than Einstein's escape of creating a non-mechanical excuse, non-mechanical bent geodesic, whatever the fuck that is. All right, so anyway, I want to just get to the point that it's all about the communication between objects. And so you're saying that, okay, we get the gravity's, that's what Newton really nailed down, is that you have this invisible communication. You have to come up with some explanation. And the clearest explanation is, it's like light. It's like photons. We don't see them moving around. We can only see them under certain circumstances where we actually deflect them. You can't see a laser beam. You can only see a laser beam if you have a smoky environment that reflects the light into your eye. So you don't see the photons that are actually getting to the destination. You only see the ones that go into your eyeball. So it is, this invisible force. You can understand, the concept that it is able to apply, send a message. And it just seems so, like they were so close to coming up with some sensible description of what a photon is. So again, they went with some kind of, because they didn't show each other laser beams, okay, they somehow turned, I would say that for me, the sun was always something that, I don't know why this is failing to write. Maybe I just had it out of its, maybe it's finally out of ink, and maybe that's it. Maybe. Let's see. What can I write on? I don't have anything to write on in here. Plastic isn't the best thing, Gary. Close enough. It worked, I think. Maybe. All right, there, we're starting to get somewhere. All right, so rays was, for me, how I always thought of how the sun, what it was doing. It was shooting rays at me, okay? And then obviously these other people, maybe you somehow see this sort of thing, some sort of wavy crap, that I can't make much sense out of it, because it, well, at first because I've seen a laser beam, and that's, once you've seen a laser beam, I think you're sort of done pretending waves make any sense, right? I mean, what's a laser beam? It's doing some kind of thing like this or something. What's your theory of how a laser beam waves? Doesn't make any sense. And photons are. I'm going to argue photons are really big because they're 500 nanometers of polarization and frequency, so they're a pretty big object, but they're very small from our perspective. And clearly they land in very small locations, and they cause their effect by hitting very small locations, and they can get through a very small slit. So they're not a big object, but they're they obviously do land as a pixel. Okay, I mean, so many experiments demonstrate that's what they are. They're a clump, as Feynman would say. They come in chunks. They come in as an object. They don't come in little pieces that become an object. They're just, boom, they're an object. And it's all or nothing is the simple kind of argument. And it just seems so sensible to understand the frequency as just being a distance between clumps. And it's for me, it's shockingly simple. It's so simple, it's so sensible, it's such a perfect. Why is this not working? Don't really know. I really like it because of the fine point, but I guess it needs to be it dries out too quick. Frequency. So it's just this, So the rays are little bits of stuff, okay, at a distance, and that's your frequency, okay? That's your little distances between your waves here, and it's just little bits at that frequency. And then I'd argue to make polarization, you just recognize that the little bits are a little bit out of alignment. That is, they're parallel to each other, but they're not following directly behind each other. And so there you create your polarization. So the photons have a way of hitting the surface, a direction, okay, and it's like antennas. So I've been over this so many times, but I can make an antenna, and you can sort of understand the electricity takes time to get up the antenna, and so it's going to create this compression in the space that is going to push electrons on the surface. It's going to compress the space, and it's going to compress it in this kind of manner through time. This part will be further along than this part here, and this is just a compression in the field where the little bits are closer to each other. They have a higher frequency because you've pushed on them. So these pushed together ones are traveling sequentially in space in this kind of matter off the radio antenna, and it's just going to hit the antenna on the other side, and it's going to do the same thing to when it hits that surface. It's going to hit one part of it first and move right up the surface and push, and so it's going to do the same thing. It's going to create electricity. It's going to just push right up the antenna, push the electrons. So it makes perfectly good sense that it would be antenna polarized. That you'd have to have the antennas lined up with each other for the signal to be received. If you have it this way, you're going to receive a tiny amount of the energy. And the closer you are to perfectly vertical, perfectly aligned with the antenna producing the effect, the more of the signal you'll collect. So all of that makes perfectly good sense. And all you're collecting is the frequency, right? The fact that you have pushed, and compressed, taken a big frequency, or a random frequency, and turned it into a decipherable frequency. I guess we'll use the other pen because that one's just not working. All right. So the idea is electrons are being moved by the force, the little bits, and the little bits at the same time are being changed in where they're going or where they would be based on where they hit an electron, where they reflect. And it's just a matter of the little force bits carry all of the motion, and it's just a matter of whether they're stuck to an electron or a proton, or whether they're freely flying through the universe at the speed of light. So if they're pushing matter, they're going to go slower, and that has a whole bunch of implications that explain gravity. So I guess I'll get to that. But the simple argument is you can understand that's the communication mechanism is just this. It's these little bits of energy, okay, moving the speed of light, and they all have a vector, okay, and they all can apply a pushing pressure, and and that simple explanation does work. And if you just add a couple of features to it, I mean, really, I know for some of you, I've done this so many times, but it's the story. I mean, until somebody pays attention to the story, I don't have any other story to tell than this story that needs to be accounted for as, a very good explanation, a simple explanation for the physical, what we physically see. And the fact that is, this physics has never considered anything else but their wooey explanations. They haven't played with any other idea at all. And it's all based on these, preposterously bad assumptions. So, going back to Descartes and Newton and Galileo, they were working through a system that was getting better and better. I mean, they were getting clearer and clearer in terms of this idea of how energy is transferred between objects. They were doing experiments, pendulums, all this other stuff, finding out lots of relationships. And there was absolutely nothing that indicated there was something broken with the simple idea of momentum being the thing transferred. I mean, for thousands of years it worked on levers and balances. It made perfectly good sense that you just figured out mass and velocity. And if you measured the mass and velocity of any objects that were in a tug of war or that were in some oscillating mechanism, that as long as the mass and the velocity were equal, that's all you needed. That's all there really was. That's how you calculate the actual force something has, is how much force has it collected. And the way you measure how much force it's collected is how fast is the mass moving. That'll tell you how much force it's collected. All right. So it really shouldn't be an argument in terms of momentum worked, and then for no good reason, Leibniz, a very religious kind of kooky fanatic, proposes, without any physical evidence. I mean, he didn't offer some sort of experimental evidence and say, here's the proof. He just suggested, without any evidence, that somehow 4 pounds dropped 1 foot was the same energy as 1 pound dropped 4 feet, even though they don't have the same momentum. So somehow two things with different momentums could somehow impact the scale, the same. So I mean, how could two things that have different momentums hit a scale and weigh the same? They can't. So how could they have the same energy? And somehow that reasoning survived, even though it didn't survive the actual time in which it was proposed. So Leibniz was buried in nobody. Nobody accepted the theory. It was a cult, religion. And then it was just emerges in the 1700s because of this silly experiment, frankly, where round objects were denting, not dropped to penetrate clay, but just dent the surface of the clay. And so you could have something going twice as fast create a dimple in the clay that was 4 times as large. And it was only because it was like the difference between a pointed arrow and a dull arrow. The pointed one will go deeper. It will create a bigger hole in the clay. And a round object, obviously, the more energy it has, the more velocity it has, the more it's going to be pushing clay sideways than straight down. And the less energy it has, the more down and the less sideways. So it's going to do more work. It's going to be able to displace a bigger dent in the clay until it equalizes by going deep enough to go halfway past the halfway point. Then the two objects become equal again. But the competition isn't a fair competition until they both penetrate the clay past their halfway point. And the fact that physicists can't understand, I can't convince them that that's an absolute truth, that it's a bad experiment. Even that is such a giveaway that this isn't about the truth. It's just about defending a religion. It's defending a tradition. And I don't know why it's the preferable tradition to defend the physics of a religious kook, frankly, who didn't have any evidence. Again, who didn't provide any experimental evidence, and didn't even provide any reasoning why this new theory of mv squared fixed anything. Because there wasn't anything broken. There was no substantial brokenness in what people understood. And it does break when you create this new rule and say that there's this mv squared conserved property of energy, because now levers don't make any sense and pulleys don't work. Lots of things are broken because of this silly theory. It doesn't even work in the simple logic of a space being in space and using an exhaust to move you. So even the third law is thrown in the garbage, Newton's third law, because there's no, I could use the example from the Gravity movie and the fire extinguisher, using any exhausting particles. If you calculate the kinetic energy of your exhaust, it won't be what you get as an equal and opposite reaction. You're only going to get the equal and opposite reaction to the momentum. It's the only energy that will move you. So how can you believe in an energy that can't move you in space? In one of the cleanest environments I can put you in, where any motion can be separated from all other motions, you can't make this theory work. It doesn't do any work. It doesn't play any role. It won't land you on the moon, for example. If you use it to figure out how your lunar module is going to land on the moon, you'll fail to land. You'll crash, because it doesn't happen that way. Your exhaust is your momentum. It's only the momentum of the exhaust that matters. Kinetic energy is useless information. It's a big deal, and you can't get physicists to pay any attention to that big deal. All right, let's see what we got here in terms of chat. I guess we'll do this live chat thing, and then I'll pop it in a window so I can see it easier, and all of that craps. All right, forced reality. Science perhaps overcomplicated physics without proving how physics can be as complicated as they claim. Well, again, without having good reason is my big argument. They didn't have reason to resort to these wooey explanations. Even the dark matter one, come on. The idea that, okay, things are redshifted. To come up with this idea that the redshift is happening because somehow everything in the universe is flying away from everything else in the universe. That doesn't sound like the first, cause you come up with. And to just recognize that all of these cases rely on photons that have traveled billions of light years. Well, obviously, things that have traveled billions of light years might have encountered something to cause a frequency shift. So it's just really bad. Let's see, Blue Moonshine hasn't made a video in a few weeks. I wonder what happened. He made one every few days. Well, that's not really true. I think he's only made like 4 videos related to these subjects. But obviously I called him out on being a cheater, and he knows that's what he did. He did cheat. Okay, so, he's got the air track. He could do all kinds of experiments with that air track, and he doesn't do anything, right? So, that's the big giveaway, isn't it? You got the hardware. It take, in a half hour, you go through, 15, 20 interesting experiments regarding things banging into each other and things being launched by different physical mechanisms. So you could use a spring, and you could use a rubber band, and you could use a pendulum. You could use very different things to see. He made 11 videos where? Where do you make 11 videos? I didn't see any. Unlisted ones? Well, yeah, how do I see his unlisted ones? Sorry, I didn't see any of those. So, whatever. Let's see. They are very nicely edited. What are you talking? What are you talking about? You're insane, Scott. I don't even know what, I don't know. Do you know who Blue Moonshine is? They're crappy videos. I mean, they're insanely annoying. you know, ooh. It throws babies crying in them. I mean, what kind of, that's like whatever, 1946 internet? I mean, really? Come on. Ugh, whatever. So, whatever. Maybe I can science that. Yeah, well, yeah, he didn't make that many either. I don't even understand where you're saying the unlisted ones. Where are the unlisted ones? I don't know what an unlisted. I make unlisted videos, okay, now and then, but I haven't seen anybody else making any unlisted videos. So where the hell is that? IDK. Yeah, I don't know what that means. All right, so I don't know. I don't get people. So just stop trying. I shouldn't even try to communicate. But yeah, what else are you going to do, right? I mean, that's the whole job here, is to try to talk to people, but you can't talk to people. You're all nuts. Yeah, people are just, I don't know. There's a very high probability of, monumental lapses in reasoning and logic. And it's getting so bad now, these videos with these fucking AI videos. I mean, it's great technology. It's really nice that, they can write a nice script and it just goes, it says the same thing 700 times exactly, all kinds of different ways. And so it stays a little bit interesting because it's saying the same thing 675 different ways. But it's just terrible. They're I mean, you can't tell if it's the real person or not. I mean, they have Brian Greene, getting, a bunch of videos where he didn't say any of this shit in the video, but they're using his voice and reading a script, and you're like, you can't tell the difference. I mean, you can tell a little bit, you have to kind of work at it, but at first impression, you can't tell the difference. That's just really bad form that people can get away with doing that shit. Check Blue Moon Shines playlist. What the fuck does that mean? What Blue Moon Shines playlist? What is that? What's Blue Moon Shines? I've never even heard of Blue Moon Shines. Is that his channel, Blue Moon Shines? I don't remember the Shines part. Anyway, have you seen the recent video uploaded by Space Talk with Brian and Neil deGrasse Tyson on AI and consciousness? Well, who the fuck could care? Moron and idiot. So that's not going to be much. I'm not going to find it that interesting. But the very fact, even talking about the fact that an AI would be conscious is just so fucking stupid. It's not going to be a feeling machine. Making a feeling is insanely complicated. We can't do it even. There's no even way to even construct it without jeopardizing, taking the risk that you'll insanely torture it. Because frankly, if you don't give it a mouth and the capacity to talk first, it's, you could just create a horrible, you're just torturing something. So what the fuck is that? It doesn't make any sense. But why would an AI be conscious? There's nothing that connects consciousness to thinking. Consciousness isn't just about thinking, it's about feeling, and it's about, doing this. But I mean, I'd say the biggest part of it is feeling. Feeling is the part that's the amazing part. The thinking part is, that's just an abacus. You know what I mean? You can make lots of machines that can do math. They can do, the basic logic of recognizing that if, all of the letter A's are blue and all of the letter B's are red, and that kind of doing that kind of parsing and set math. But yeah, that's not the same thing as feeling. But whatever. I just irritating that people keep changing the damn subject. All right. So anyway, back to what I was arguing. So the simple idea is that the universe is just pushing mechanisms, okay, and And again, we have this huge advantage now, unlike Newton had, of where we've seen charges in an elemental sense, that we know you can make little tiny ones, that there's the idea of an electron, okay, and the idea of a proton. All right, and these things are essential because this is the north-south thing, this is the plus-minus thing, okay, and the idea that you have this relationship, this perfect relationship, where they have the perfect same strength, and you have these perfect mechanisms for creating attraction and repulsion in perfect proportions. The repulsion is as strong as the attraction force. A really interesting mechanism. And the fact is, you can make it this simple. All you need to have is something that pushes, okay, and the two charges, and that they have the same character. And so I just make a rule, okay, that if if an electron force hits an electron, it can move the electron. And if the electron's already moving in the opposite direction, well, then it can slow the electron down. So that means that if it already has a Sisyphus pushing, this way, then the two of them are going to compete with each other essentially, and they're both going to reflect. They're going to get rejected, and the electron will be losing a little bit of its velocity, okay, because it would lose one of the pushers. So you have a sticking event, where you absorb, okay, where you absorb the Sisyphus, the energy. The Sisyphus now pushes on the electron. It doesn't go as fast as the electron, but it goes fast enough, and it goes fast. And you could have 3 or 4 Sisyphuses pushing on the boulder in the same direction, and the electron could go even faster and faster and faster and approach the speed of light. Again, and then everything will be equalized, because now the Sisyphuses will be going as fast as they were going before, and you'll have the benefit of this big boulder that's also going almost that speed. And then you have the simple idea that you could have a reflection, so of a counter force, and so it's just the third law kind of thing. And then the simple argument is that you have this unique event where if the electron force hits a proton, it comes out a proton force. And likewise, if the proton goes into the electron, it comes out an electron force, and that ends up creating perfect radiators. So you end up with plus and minus mechanisms, north-south mechanisms that are doing this. And that's really what this is what Maxwell's math really indicates is happening. There's none of this swirly crap. They draw all of these field lines where they say, well, what would a negative charge do if I put it here, or positive? So I make a positive charge and I put it there. Which way would it go? And then obviously, it's going to go towards the opposite, and it's going to go away from the same. And so you can draw a line that would, duplicate what its function is going to be. But those lines are all arbitrary, and in a sense, depend on how many charges you have in the location. So it's like when they do iron filings around a magnet. Those aren't real lines. There's not lines in those exact locations. Because if I make the iron filings thicker, if I make them smaller, the lines will be in a different place. Because it's really just about the new magnets you're making. So when you spread the ironing filings, they're piling up and making magnets that are all oriented in the same direction. So that's why they're repelling each other. Each one of those little lines is a new magnet repelling the magnet next to it. And that's arbitrary. Those lines aren't showing you anything that's moving on those lines. Nothing is moving on those lines. These are just 2 radiators. These are 2 light bulbs. One's a red bulb, one's a blue bulb, and the simple rule is that if the energy they're getting from the field. So if a blue comes in this way, it can't hit this blue here, all right? Because it's going to be turned into a red, and then the red will go right through the blue and come out blue again. So all of that energy between the two is gone. There's no way a red can push on the red, and there's no way a blue can push on the blue. So there's no pressure between them. So they're moving into each other. And it just works perfectly. So it perfectly duplicates charge. I'm just saying this is, frankly, I mean, of all the things I could argue, this is the most, what I'd say is my invention, so to, so to argue. And it's so simple and it works. I mean, it duplicates charge. It does exactly what Maxwell would say these charges will do, this simulation will do. It's just a fact. It happens. It works. And it's so simple. And, the fact that you can't get in people to even consider that, oh, that's the simple mechanism. Okay, so now we know how energy is being communicated, that it's just about these electrons and protons. And the fact is they are pushing on each other constantly, pushing and pulling. There's no pull, there's just push. But their absence of push on each other. And, that's the mechanism. And it really, it's just very disappointing that, people won't even pay attention enough to say, okay, yeah, that's a really simple mechanism that actually does create the effect. It creates the appropriate repulsion and the appropriate retraction, and in the right proportions, and it works, and it satisfies the conditions. And then you can take that and just say, yeah, this simple mechanism of this force stuff. So I just take these Sisyphuses, these electron ones are going to move electrons. So that means they're going to move the stuff on the outside of the atoms, right? And that's the easy stuff to move. That's the stuff that's not bound as well. So you just say, oh, okay, so I put some of these little Sisyphuses at a frequency, right? Yeah, now I made a photon. So a photon isn't something, complicated, wavy, mushy bullshit. It's just this force that's now going to interact with a surface. It's going to hit it. It's going to hit the electrons. And the fact is it's going to impart its energy onto those electrons. And so if the electron's going out, it's going to push against it. And if the electron's going this way, it's going to collect it and go even faster away. So it's going to collect the energy, essentially, the information, if you want to call it that. It's going to interact. And so if the object is hot, well, then it's going to increase that frequency on average because it's going to be pushing out faster than it's retracting the electrons. And if it's cold, it's going to do the opposite. But it just makes perfectly good sense in terms of how it's basically absorbing the energy of the event, and the energy of the event carries information in the sense that it has a history. So if the photon is a blue photon, it means it was part of something that was a very high energy event. And if it's a red photon, then it's a lower energy event that created it. So that message is going to be sent. And so those are the ones that we account for, the photons we get to see, okay, with our eye. Our eye doesn't detect the red Sisyphuses, okay, because they can only move protons. And protons are in the tiny nucleus, really stuck inside of the nucleus, really close together in tiny locations. So it's really hard to hit a proton, and it's really hard to move one, frankly, because it's really close to each other. So they get, just like with gravity and how the closer two objects are, the more they're going to get smushed into each other. The same thing is true for these charges. And so when the protons are in the nucleus with the little electrons between them, and they're all compressed inside of a sun and gotten very, very close together, they stay very close together, and they're hard to knock apart. So you have to hit them with a lot of Sisyphuses to change their condition. And there's nothing to make those extra Sisyphuses, nothing simple anyway. So we don't really see that force, the red half of the story, the proton force half of the story, because the protons are so much harder to move. But it's there. It just doesn't ionize. I mean, that's the key thing, right? The only way we really see photons is because of this idea that they can ionize an atom. They can break the bonds between two atoms. you can't break the bonds by fiddling with the protons. You need to break the bonds by fiddling with the electron pressure. So anyway, Blue Moonshine has a playlist on his channel called Debunking Draft Science. It has 4 private videos. So I don't know. Yeah, so I don't know who watches private videos. So who are they for? What, do you have to be a member or something? So I don't get you. And totally has made over 10 videos about you. I don't know. Well, I'm just saying, where the fuck are they? You know, you're saying they're private videos. Maybe they're unlisted, but you know. And so what are they doing? Lying? I mean, what, you know, what's the point? I mean, the guy obviously is comfortable making false claims. He even, you know, used my street address, you know, in a video, you know, the name of the street. And you're saying, who does that, right? I mean, you can't make an argument that, oh yeah, that's public domain, and we have. No, everybody knows you don't do that on the internet. You don't. Nobody does this, right? Even if you're going to use somebody's real name, you're not going to bother, you know, announcing what street they live on, you know, what state, what county. Well, you're not going to do any of that shit. So he is just a terrorist, for fuck's sake. But he's saying he made 10 physics videos. I mean, I don't know what the videos are. I'm just saying that I would argue that I doubt there was any physics in his videos. Because if he wanted them to be seen as physics videos, they'd be on his channel as physics videos. So, whatever. I really don't want to argue about his conduct or his videos, because if you think they're relevant in some way, you're a fucking idiot. I mean, did you see the fucking video? I mean, he does this rubber band experiment. It clearly, the software failed to function correctly. There's just no doubt about it. It didn't function correctly. And then he claimed it's a valid video. I think he obviously scraped his fingers against the cart. And, you know, so I mean, you either say it's a software glitch, or you say somehow he made the experiment not work right. And that's why you got those weird results. No, I'm just saying he has made more than 4 videos about you. Well, whatever. I haven't seen them, so I don't care. You know, I guess nobody else can see them either, so I don't know who's seeing them. You know, nobody goes to playlists, right? I mean, on my channel, I have playlists that nobody's ever clicked on, you know. So I just, you know, I just don't know, you know, these videos, how many views of these unlisted videos that are only in the playlist, how many video views have they gotten? But anyway, I mean, like I said, I guess I'm only interested in physics arguments, and he really can't make a physics argument. He's just such a dumb, slimy pile of pus as a human being. And his little rotten, stinking kids are the only people I'd like to talk to, in the sense that, you know, they're going to eventually see what a lying sack of crap he is. And that's the only redeeming part of him having children, is that someday they're going to have to admit that their father is a putsy, queer, weird, fucked up motherfucker. He likes dancing. He's a little prancer. Alright, anyway, it's just enough of this shit. God, he's just such a despicable shit. So thank you for distracting me pointlessly, fucker. Anyway. Alright, so where was I? Time to erase, I think. That's the link to the playlist. Well, the link didn't show up, so I don't know what to tell you there. I can find a playlist link, I guess, so that shouldn't be that much trouble. But like I said, that's just why should I be interested in a private video, whatever it would be? I mean, a playlist video, let's just say, a video that's not accessible on his channel. It doesn't seem like a video he wants anybody. I mean, I made one to him that was, you know, a response video that I didn't list because, yeah, I don't think he deserves a rational or fair response. He's just a pile of human garbage. I mean, to put again, there's absolutely just no reason to use my name. I've explained why I don't live at my house. I live in somebody else's house. Why would you dox somebody for no reason? It's just ridiculous nonsense. Yeah, well, the problem is the other people doing the simulations have their own lives full of horror and nightmares. And so, yes, both of them have been unavailable lately, and so I haven't had anybody to work on the simulation. I think we're probably going to just concede. If I get one more update out of the guy, then I'll just make the code public domain and see if somebody can do the rest of the advancements in it. But I just want to get it working as good as it should. Alright, whatever. Please don't call me names. I don't care. You don't want to be called names, and don't go near me. Whatever. I'm a good person. My father recently died in a car crash, and I'm down with the flu. Yeah, well, that all sucks. But I don't know exactly what you're arguing. I'm just saying, I don't know whether it was you who brought up this shit, but I'm just saying I have a right to complain. Because I don't think he's made any arguments I need to pay any attention to, and if you think he has, well then tell me about it. But some vague notion that he's made 10 videos that aren't public, yeah, I have some right to say, what the fuck is that about? But anyway, I wonder what he would think of the double slit. Well, like I say, he's just conventional, so I'm sure he doesn't know what the fuck, he doesn't have any concept that, oh, you mean we're supposed to think about this logically? It's supposed to make logical sense? Oh. I mean, yeah, like I said, it doesn't take much work to figure out that the wave theory doesn't work, right? I mean, if you consider the wave would have to be coming out of the middle of the slit, right? So you have a double slit. The idea is okay, yeah, it's worth doing. I mean, the idea is pretty simple, right? So if and so the only way they get out of this is because they do this infinitesimally small slit thing. But you just know that if you were to draw it, this is what the double slit is, right? This is two waves coming out, and the two waves are going to cross each other, right? Well, the fact is, this math, if I take this location, the center of the wave, and I use that to draw my vectors, I won't get the right answers. Just an absolute fact. And the only way I can get the right answers is I have to use these surfaces. I have to use the surface locations to draw the vectors. They're the real point source. I have to draw the points from the surfaces to get the right answer. So the simple truth is, if I treat it like water waves, it won't work. All right, the only way they make that happen is, right, they turn the double slit into the single slit, because they make the opening so small that the two surfaces you can't create a length of line a wavelength greater. There's no location you could go to where this line will be a wavelength greater than this line. So you can't create any fringes at all from these two surfaces. And so all you really have is the two slit again. Now you're just back to the two slit experiment, because this surface is in the same location as that surface, this surface same as that. So all you have is two surfaces. So that's why when they do the double slit, they end up with the single slit pattern. I mean, that's the big joke, right? Is they're calling it the double slit, and they end up with the single slit pattern because they're too stupid. And everybody should notice that, that the real double slit pattern has the little dots inside of it, right? Everybody knows that's how the real pattern works, and the real pattern has these clear relationships, right? This is always an odd number. 1, 3, 5, 7, 9, 11. It's always an odd number here in the middle, which means, yes, it's just really two of these nodes crossing over each other, and that'll create your double minus 1. Double minus 1. So it's always double whatever this is minus 1. And that's exactly what crossing over would look like. That's exactly what, if they just overlapped each other, that's exactly what you would get. So there's giveaways that are just that obvious. And you can't get anybody paying any attention again. Not a single one of these people defending science and the truth will concede, Well, that's a hell of a reveal. Okay, that's saying something pretty obvious about the pattern, isn't it? That it works out that way, that this double maxima ends up being a perfect description of just having the two single fringes overlap, that you just have two fringes in the center. And you have two fringes because you have two separate patterns. You have a pattern from this location going this way, right? And you have the pattern from this location going that way, you know. And so it's obviously two different, these are two different compasses. Okay, even though they're close to the same, they're still different patterns going out, and that's why the two overlap. And you know, it all works. I mean, you know, you could just do it from these lines alone. So even this distance works perfect. So if you go from the edge of the slit, and then you go from the edge of the other slit, this tells you exactly what you're going to get, right? Because you know that this, whatever this number is, if it's like 15 and a half wavelengths, well, you know that this has to be an off, right? Because it's a half wavelength. So you know this is an off here, right? And so then you know this pattern has to be on, off, on, off, on. So you know that the center isn't going to be dictated, right? And then, you know, even people like Professor Lewin used to do this thing where they'd say it's non-negotiable that the center, right, has to be an on because it's equal length. But that's inside of a millimeter. It's only equal length inside of 1 millimeter. The pattern's a foot wide. The double maxima on the screen is a foot wide. What's happening inside of 1 millimeter has nothing to do with the gigantic pattern. So it's just so funny that they don't even realize that the part that's doing the same line isn't this. The fringe out here and the fringe out here is doing this. Okay, they're doing this. They're not doing this. It's inside of 1 millimeter that's doing that. The rest of that pattern is being created by fringes where the lines are going in the same directions. I mean, it's just so obvious, just so annoying. All right, let's see. Have you tried using AI in Visual Studio Code? I know, I haven't tried any of it to work out bugs in your simulation. Well, I don't think it can, frankly. It can only duplicate software that something's already done. So unless you're doing a module that's already done, it can't really invent. So, you know, if I tell it, you know, I need you to figure out how to perfectly randomize 10 million or 10,000 little vector arrows, you know, it's not going to know the answer. It can only know answers that somebody else has used. You know, and so then that's the bug of it. And I already figured out a way to fix the problem. You know, the problem was you know, it's really hard to create random. You know, especially when you have to reuse the bits that go in and out of the simulation, right? You can't create a new bit every time something leaves the simulation. You can't create a new one, so you got to reuse the old ones. And so if you're losing red and blue, but you're losing them in different numbers, like 10 reds to every 5 blues, and then later on it'll be 10 blues to every 5 reds. And all this gets very complicated. But the problem is that if you use randomness in such a small circle and with such a density, it ends up being too chaotic. You know, there's just too much chaos. And because it's not... It's random way too late, okay? So it has little pockets of random over time, but it's not really random in small units of time. And so everything gets pushed way out of whack. And then, okay, well, you know, it fixes way out of whack this way by going way out of whack that way. And so it's just too jerky. And so obviously I figured out how to fix that by just making sure that when you're putting the force in, you always put in an equal amount. So for every time a force bit comes in this way, another one has to come in from the opposite direction. And by doing that, it'll get rid of that extra noise that was really preventing the simulation from working as well as it would have. Well, anyway, it's more information than you need, you know, that you could use. But anyway. Yeah, well, it's good. You know, like I said, maybe when I make some of this code public, and then you can play with it. With AI, I'm just not, I'm not skilled enough in knowing how to interact with AI modules to know how to get the best use out of this stuff. There's a learning curve for everything. I just don't know how much learning curve there's left in me. I'm a tired old man. Frankly, I'm an old dog that doesn't want no new tricks. It's pretty glaring that when you accept photons don't wave, you can reasonably see how the double slit works. Yeah, I don't know if you can. I mean, it's not obvious, but there's just things you have to go through it in your head, and then you realize how sensible it is in a sense. Like, one of the other issues was, once you accept that the surfaces are causing the problem, you have to figure out how the surfaces are causing the problem, right? And so that's another interesting part. I mean, that was another simulation the other guy was going to work on, and then his father got sick and all this and that, and it's just everything goes to shit. But the idea would be, say this was your surface, and we'll concede that there's electrons, okay? And the idea is that we know that everything has, everything's jiggling, right? Because everything's hot, first of all, and it's really hot, frankly, right? I mean, in Kelvin, we're really hot, okay? It's not like we're a little, we're pretty fucking hot. Anyway, so obviously they're moving in and out, right? So you can understand that if the bits of the photon are coming through, and they're going to, some piece of the photon, right? That's a little bit here, this is a photon. Well, one part of the photon is going to actually hit one of these electrons. And the electron's going to be either going out or it's going to be going in, right? So you can understand that part. So what's going to happen when this bit hits the electron, right? So the electron's going out, it's going to get hit. Now it's going to be going this way, right? So instead of pushing this way on the field of energy, straight, pushing straight into this field and compressing some photon coming this way, instead it's going to be going that way. And when it goes that way, it's going to compress into the field that way. So now it's going to push pressure, compression that way. And you can see that if it happened twice, then okay, it's going to be bent twice as much. So it just kind of depends on, you could also understand that when the electron first leaves, it's going its fastest. So right near the surface, the electron has the highest velocity, and it's slowing down as it pushes out, right? Because it's hitting force and it's compressing it. So it's getting slowed down as it goes. So it starts off going, let's say, half the speed of light. And then it's going, whatever. Then it's going 4/5, and then it's going 4/10, and then 3/10, and then 2/10, and then 1/10. So you can understand that's what it's doing. So depending on how far out it is when it hits the piece of photon, will decide whether it's going to bend a little bit or bend a lot, right? So the faster the electron's going, the more sideways it's going to go. The slower the electron's going, the more of an angle it's going to get. So the trajectory of the electron will be dependent on how fast its motion is, okay? Because obviously the force of the photon, or the piece of the photon, always has the same energy, so you can't change how much energy it has. But how much energy the electron has, you can change. So that gives you this idea of why some of the energy goes at a 30-degree angle, and some of it goes at a 40 and a 50 and a 60. And so it explains all of that. Now, the other simple truth is, right, is once you've figured out why you've got these bits of, again, everything has to be understood as the electrons and protons are moving. And as they move, they push on the field. And then when they move this way, they relax the field. That is, they open the frequency. The reflections happen I'm red shifting when I do this. I'm blue shifting when I do that. It's the key function in the universe is red shift and blue shift. Really key. More key than people realize. But it's really the whole story, frankly. So I have my surfaces, doing this, you know, basically randomly scattering, okay, pushes. So it's pushing this way, pushing, you know, electrons pushing in these random directions. So the photons were all going this way as rays, and now their energy on the surfaces here have been converted into this. You can sort of understand, because of those electrons moving quickly in and quickly back, you know, or slowly and then quickly, you know, doing exactly the opposite in the opposite direction. This is what's happening. And that scatter, once you've created that scatter, and it's only out of these tiny portions of these photons, right? All the rest goes straight through. All right. And obviously, the narrower I make the slit, the more likely all the photons are going to have a piece of them broken off, right? So if I make the slits really narrow, less than the wavelength of the light, I'm going to get a ton of fringe, because all of the photons are going to get a piece knocked off. And all of that fringe light is just 50-50. I have a piece going here, and I have a piece going here, and they have to hit in sequence to the frequency. So if it's blue light, it has to be let's say 500 nanometers for red. It has to be that kind of difference in when it hits the surface. So this one has to be 500 nanometers behind when this one hits. This one hits, and then this one hits 500 nanometers in time later at the speed of light. And you end up recreating the photon. So you're making the photon out of two sources. So without the two sources, this is why a single surface doesn't create a pattern. It's because it doesn't have a second source. And the only way it can create a pattern is you have to have a very, very lumpy piece of paper or something. So if you have a very lumpy surface, then you can create a little bit of a fringe, because basically you're going to shoot, you know, some of the light will go this way and some of the light will go this way. Not scatter this way and that way, but it'll scatter up and down. So you can actually create a fringe pattern. But yeah, you have to have a surface that's really irregular, okay, for that to happen. But if you use a regular double slit with smooth surfaces, all you're going to get is motion in those sides, and you got a 50-50 chance. 50-50 chance you're going to go in phase or out of phase, in phase, out of phase. 50-50 chance. You only have two choices. You're creating a frequency that's getting close to being in phase, or you're creating a frequency that's close to being 150 degrees out of phase. So that's all there is. There's just getting close to the center in phase, halfway out of phase, and that's it. So those are 50-50 chances that you're in one of those conditions. So it perfectly explains, all the fringe light is created by surface light. And all of the math that works explicitly well, you measure the distance from the surface. If you ever measure the distance from the center, you're not likely to get the right answer, unless you make the slits infinitesimally small and have eliminated the distance between the surfaces. It's just so obvious. All right, it's pretty glaring that you accept photon. Let's see, it would be simulating your push model. Let's see, have you tried? Okay, I would like to take a crack at simulating your push model. As I've been using several AI agents to create functional code. Oh, okay, I didn't realize you said they'll take a crack at it. Well, that'd be great. So if I can help you in some way, if you want to do I can make you a video and give you advice. And you can email me or whatever, however you want to communicate. It's pretty glaring that when you accept photons don't weigh. Oh yeah, we already did that. Okay, where is the best place to get your core theory as a set for rules? I could start plugging into a simulation, something where the core theory and resets are clearly spelled out. Well, I could almost do it in this video. It's that simple, frankly. I mean, it is these simple rules, so I'll give you the simple rules. Yeah, since I'm here, and it might show people just how simple it is. I mean, there's nothing. The only thing complicated in the math is you have to have some shortcuts to creating you have 360 degrees. Obviously, we're going to cut the simulation into a two-dimensional to start with, I would say, right? Because 3 dimensions will be insanely complex. And so you're breaking some of the rules. But you'll get some of the same effect is still there. I mean, obviously, some things, like the inverse square law and certain other things, obviously, you can't have something going in 2 dimensions, separating in 2 dimensions, and moving in the 3rd dimension. Obviously, you can't do that. So some things break down a little bit. But, for the purpose of showing, it's not too bad. I'm happy to start from scratch. Just need a core parameters to start building the simulation. I too am old, but I've been working with AI for quite some time, and it can be useful for refining code. Yeah, well, I've seen a little bit of that. I mean, I didn't. Somebody else did it for some kind of code. Oh yeah, I might have modified a file upload code, I think. I actually asked AI, and it gave me the right code, so it did work. But anyway, all right, so the simple argument is just have 2 things in the simulation, right? So got electrons and protons, and so it's best if you can make the electrons and protons sizable. And then you'll have 2 kinds of force, okay, red force and blue force, so if you want to make it that simple. And so, and then you have a universe, okay. And so the simple fact is the little bits move the same speed when they're free. So they're always going the speed of light. So whatever that speed will be in your simulation, that's the speed of light. So obviously that should be variable. And the size of the electron and proton should be variable, okay, but it doesn't have to be, but I'm just saying it's probably best to create it so it can be variable. All right, and so the idea is you have to have to simulate the universe, that is the big universe, this has to all come into the simulation in a randomized, okay, manner. So the external universe, we're assuming there's no moon right next to this, or there's no planets, so it's getting a very even push of energy. So it's all very even being pushed into the universe, and it just goes through the universe, and if it doesn't hit anything, it just pops out, okay, and then goes back in some random way. But like I said, the randomness has to be fairly consistent. And what I found was it's probably best to create some mechanism so you can say if you're putting, an electron force comes in from this side, then one should also come in from this side. If you pair them, that way you'll get a lot more regularity where you won't be jerking things around too wildly in the space. So they'll behave much more naturally, I would argue. All right, so that's all you got. You got little bits of force moving at speed, and when they hit the matter, okay, they can stick. And so the sticking rule is if the thing isn't moving, right, so if this is a proton and nothing else it doesn't have a suffix stuck to it, there's no motion, or it's already moving in some direction that has a vector, okay, in the same direction as this vector. All right, so this is the one I'm adding. If it's already going this way, something that on this 50, in the parallel line. So if it's going this way, then you're going to basically say, I'm going to add this force. So if it's already got one suffix pushing this way, right, you're going to add this one, and you're just going to split the difference in terms of the vector. So now your motion vector will be this way, and it'll be 2 suffixes worth. And so as you pile up suffixes, just say it's 10% of the speed of light per suffix. And so obviously the first one goes 10%, then the second one is like 9%, and then the third one's 8%, because obviously you can't go as fast as the suffixes. So, when you have 100 suffixes, you're still not quite going 100% the speed of the suffixes. All right, so that prevents you from doing this, going faster than the suffixes can travel. But that's the idea, is that they just go faster and faster the more you collect in a direction. Now, if a particle hits it from the opposite direction of its motion, in some vector that has a component in the opposite direction, then it basically causes the reflection. That is, so the piece that was hitting this way reflects back where it came from. And the R, you could do the multiply the vector thing. So if the vector was coming, let's say this vector was in this direction, and it hits this one in, say, this perpendicular direction, you could split the difference and send it back this way, or you could just send it back the way it came. So that's a choice. I'd say it's just easier to go back the way it came, so I'd say send it back the way it came. And this, from the vector you were at, you send that one back reflex. So the pushing vector, one siphicus, the last siphicus flies off, and the one over here reflects. So when the opposing force happens, 2 bits of force are flying off. So it's essentially like the force just kept going, because the reflection, okay, will be a duplication. And the force you had captured will now be released and be the reflection. So in a sense, it makes perfectly good sense that you're releasing the one bit of force, and the other bit of force just continued going where it was going, essentially. All right, so that takes care of the sticking event and the reflecting event. And then the only other event, okay, is when a blue force, and vice versa. Okay, so it's a red force going into a blue, or a blue force going into a red. All you do is it doesn't move the object at all, doesn't stick, and all that happens is it comes out red. Okay, so it goes in blue into a red, it comes out red. If it goes into a blue, and it's red, it comes out red. Blue, you get me. Okay, blue turns into red, and red turns into blue. When they hit the opposite color rock, boulder. And that's basically it, right? I mean, I could go into more detail about how to deal with the angles, but frankly, that's it. That's all there is. So there isn't that much to the simulation except for the minor calculations of these angle approximations. I mean, I think ideally it'd be nice to have them move, just like every single particle sticks, and you have a register that memorizes all these different vectors. But I think that just gets way too complicated. So you do have to kind of just take a shortcut and say, you're just going to take its vector and say, if you have 2 vectors this way, yeah, you just do this, some kind of, and if it's got 3, if it's got 3 bits of force pushing this way, and it adds 1 more going this way, you know that the 3 is stronger than the 1. So obviously it just bends it a little bit, not a lot. All of those kind of rules. But, frankly, just from the simulation, seeing it over the years that we've been working on it, it doesn't really matter how close you do that math, in terms of the directional math. It's really just about the fact that everything jiggles, and it's the jiggling motion. See, it's all line of sight. The whole way the simulation works is you got to understand the electrons and protons have to see each other, and so if they do this, something jerks them into other locations, then the force that would have given them a reaction, they're not seeing anymore. It misses them. So now they're vulnerable to, so they're doing a lot of this when they're trying to move into each other, and they just constantly are being knocked out of their line of sight. And it's that keeps them from just smashing into each other. So they really don't just smash into each other. It takes a little bit of work to get them into each other. And that, to me, is the whole reason why nucleuses have to be made inside of suns. They have to be made under high pressure because you have to get all the noise out. And you have to get them really close to each other and get them so they've pushed all the energy out. And so now it's really clean. And now they're not likely to be, you're not likely to be able to create enough noise to get them falling apart again. So anyway, let's see. I just need to. Okay, so I think those are the core parameters. If that's a snuff of a start, like I said, I can always make you a video for anything specifically you want to know. How much of this is Lesage theory of gravitation, and how much is your additions? Well, I didn't know what Lesage gravity is, so that's a feature you can actually see on this channel is I made videos about it. I didn't even know there was a thing called Lesage gravity. So, and then when I researched it, I said, oh shit, okay, yeah, it is somebody else's idea. Partially, right? I mean, it's easy to do the shadow part. I'm saying the key ingredient I've added is, you know, the whole idea that the Earth actually gets hot. It's actually absorbing the elements of the gravity. And the heat is actually the evidence of the absorption. And so what we're falling into is the heat that has to be constantly refueled inside the Earth. You have to constantly refuel the Earth. The Earth isn't an insulated object. It's at equilibrium. It has to be constantly refueled. And that's what we keep falling into, is the refueling process. Because that happened first. You know, the theft of the force coming from the Earth underneath me, that missing force happens first. And so I fall, even though it's going to show up a little bit later, but it's a little bit later. It shows up too late. And that's the simple truth. So I just keep falling into the deficit. But anyway, so I'd say it's you know, obviously I've advanced the theory a lot further than Lesage did. And, you know, and what else? Some other feature of Lesage gravity that made it fail. Oh yeah, and I have dealt in part with the drag argument, but that's another complicated one. So there was I did make one simulation on drag, and it completely failed in the sense that it showed that drag does happen. But I think a variation to the model will fix that problem. And clearly what we're not accounting for is that the gravity is the red force. That's the key point, right? We already know the force of the photons and how much energy they have. And the part we're not accounting for is the whole force in the universe is all that red force pushing protons around, because we don't see any of that. We don't, you know, we can't see. We don't have devices that can see any of that. And it's that force that's, you know, doing a big part of the gravity thing, because it doesn't have a frequency and we don't measure it on any of our detectors. We can't see it as infrared radiation, for example. Can't see the red force, the proton force. Can't see it, can't detect it. And so again, and Lesage gravity really is Fadio's gravity, and so that's the part I found when I did the research. I was a little, you know, surprised that everybody calls it Lesage gravity, and all he did was buy Fadio's papers, you know, from his family, and basically just resell Fadio's papers. And the trick was that Fadio was very well acquainted with Newton. It was Fadio that actually, you know, when you read the history, it is surprising. Fadio actually started the fight between Newton and Leibniz. So Newton really didn't want to get into a fight over precedent, you know, who owned calculus. And he sort of got dragged into it because somebody started squeaking about Leibniz. And so Fadio got pissed off. And Fadio is the one who wrote a scathing statement, basically calling Leibniz a lying, cheating fraud, and proving that Newton had written about the theory 15 years before Leibniz ever heard of it, you know, ever knew anything about the subject, and, you know, really proved the point that Newton had obvious evidence that he invented the damn thing first. It doesn't matter whether Leibniz independently came up with it, right? The only argument is who did it first, and Newton did it goddamn first. And Leibniz was trying to say the opposite, and that's when it became a real heated argument, because Leibniz reacted to Fadio because Fadio really pointed the finger and said, "You're a lying fake." And then Leibniz, to prove he's not a lying fake, post-dated, you know, so he forged a bunch of documents, you know, he tried to pretend he sent letters to people, you know, pointing out what calculus was, and they were found to be, you know, people had the original letters, and so Leibniz was caught basically, you know, cheating. And it's just funny how nobody, you know, people don't care. I mean, the truth just doesn't matter to any of these people who say they care about science. I mean, how many times am I going to have to say it about, like, Eddington? It's just so bad. How do you get a New York Times headline saying Einstein proven right on an experiment where the guy's own journal, he admits he's getting 10% of the data quality? He says right in his journal, I was expecting 10,000 stars per slide. I got 1,000. That's a gigantic degrade. I mean, it's not a little problem. It's not like a little foggy. It's not a little shitty. That's a colossally shit. You know, and so how do you know, and he says right in his own journal, I wouldn't stake my life on these results. I mean, he couldn't make it clear that the whole experiment was such a dismal, horrible failure. And, you know, yet, you know, a few months later, he's telling the world, yeah, we proved it. Disgusting. And then obviously none of those, you know, all of those factual things don't exist anymore. I mean, they still have Faraday's iron cores. They still have lots of stuff. How come this evidence disappeared? You know, that they can't even reconstruct any of this crap because the slides disappeared. You're stating that gravity is a pressure differential makes perfect sense. Yes, of course it makes perfectly good sense. That's how you create the inverse square law. It's just so obvious. How do you create... The light bulb is doing the inverse square law. How do I create the inverse square law? Let's just do the opposite of the light bulb, right? Let's just have the energy all come from space and go to the light bulb. And it doesn't matter if a bunch of it misses, right? Because the only part that's going to matter to the light bulb is the part that hits it. So from the light bulb's perspective, it's going to be, yeah, everybody's trying to get me. I'm getting bombarded from all sides, and I'm getting squished into a little tiny package because I'm getting bombarded from the whole universe. And that's exactly what all of us are doing right now. We're sitting in a universe, first of these little suns, all shooting photons at us. And we just have to realize, well, there's a whole bunch of energy that we can't see, okay? And that's what's pushing us into little balls. It's so obvious. It's so simple. I just don't know why I have to do this. Why do I have to make these videos over and over again? I mean, it's so fucking simple. And it's just overtly, oh, no, we can't have that. We can't have a simple explanation. Simple explanations suck. You know, let's have a wooey, silly, fucking fucktarded nonsense fucking explanation. So fucking annoying. Ugh. But yeah, it just makes so much sense to realize that, you know, so, you know, again, the Earth's core is, you know, they used to say it was 4,000 degrees Celsius. They're up to like 5,000 now. It's, you know, what do they think happened? What do they think that crazy amount of heat? Why do they think first that it can't get out of the Earth? Like somehow it's stuck in there forever. How do they think that happens? I mean, how exactly does it create this insulating layer, this perfect insulator? Because we can't do it, right? You can't create a thermos that actually works forever. You know, they all leak, you know. So how exactly is the Earth insulated and storing all of that energy? How's it storing it? You know, it's just silly. Let's see, right-hand turns and force going through a particle. You can go over that again, or am I confusing that with another topic? Yeah, well, don't get any more confused than what I said. So don't worry about right-hand turns. There's no right-hand turns in this newer theory. No need for them. Okay, let's just put it that way. You know, I was trying to duplicate the right-hand rule and thinking there was some reason I needed to do that, and I didn't realize I didn't need to do that because all I need to do is create repulsion and attraction. So blah, blah, blah. But yeah, so none of that. It's just this simple. Again, you know, this is the simple rule. Again, it's, you know, if it's got force bit going this way, all right, and a force bit comes this way, you know, or this way, or any one of these angles, right, it just reflects. So if it hits here and it was coming this way, then it just goes back where it came from. You know, simple enough. And then this one leaves. And, you know, you keep it simple. And then if you're going to add force, okay, so this is going, it's got 2 bits going this way, and you're just going to add a force going this way. Well, you know that the angle, the new angle is going to be something in between the two, right? So if this is twice the force and this is going to add 1, then you know your 3 will be in this direction. You know, this will be the new direction. You know, it's that simple. So yeah, no right-hand rules, no right-hand turns, none of that. Yeah, I forgot about that. I had a lot of, you know, it's a lot of trial and error to get here. You know, you can't just, you know, you can't just proof the right answer. You have to make some mistakes first. But I mean, the idea of the Sisyphus model, I should have, you know, I sort of had that in the beginning, in the sense I had the idea of swimmers and boats, you know, and the idea would be as you know, the swimmers jumped in the boat or they got pushed out of the boat, you know, and so it was a very similar idea, but I think the Sisyphus thing and the boulder makes it so much simpler. It's just, you just understand it's just Sisyphuses and boulders. And if the Sisyphuses are opposing each other, they reflect. If they're complementing each other, they add. There's just so much of this physics. You're just saying it's just so they made such a mess, and they're so arrogant, you know, about these mushy theories, and insisting we must believe in the Big Bang, and you must believe in black holes, and you must believe in gravitational waves, and you must believe in light is twice as bent by gravity, and you must believe, and it's just, you know. And then they pervert experiments like Stern-Gerlach, where, man, it's just so... See, let me do that one. So Stern-Gerlach produces this kind of teardrop result, okay? In the new modern form, it's very clean like that. You know, the old experiment is kind of ugly in that, yeah, it actually does something more like this, okay, with a hole in the middle. Yeah, something like that. It is a little different. But anyway, they're taking silver atoms, okay, and they're, you know, and they're going to deflect them through a process. So these were just little hits where the silver atoms would hit, and that's the kind of pattern you're going to ultimately get. Some kind of thing on my face. Shit. Blemishes. Anyway, irritating. Where was I? Right. So you heat an element, you create vaporized atoms. So they use cesium. I think the old original experiment's silver, so let's just stick with that. So you make it very hot, and the silver atoms fly off at varying speeds. So you have to understand, some of the silver atoms are flying off very fast, some are flying off very slowly, okay? And you're going to put them through a device to, you know, a little slit, so they'll be linear. So they're going to be flying like this in a, you know, a bunch of parallels flying like this to a target. All right. And the target is, you're going to, I'm trying to remember how they moved the detector, or did they, shit, I don't remember exactly, but anyway, they're going to detect them, okay, by them causing ions, so that the silver atom's going to hit something. The reflection is going to be some kind of ion that's going to be detectable as an event. Yeah, it's just, I'm trying to figure out how they detected the movement of the pattern. Up and down? Well, it doesn't matter. So we'll just go with up and down. All right, so the simple argument is why they use silver atoms. Well, they use silver atoms, or the other ones, whatever the hell they did use, cesium or whatever, because they're actually polarized, okay? So the key to the silver atom is it has the one electron, the extra electron on the outside, okay, one extra. So it's a dipole, all right, it's polarized. By its very nature, it's almost magnetic, except when it sticks to each other, it doesn't stick with all the poles lining up, so it doesn't make it magnetic. It's not like iron where all the nucleuses line up in the same direction and it becomes a magnet. So silver isn't magnetic as a substance, but as individual atoms, it's magnetic in the sense it's polarized. So the real effect is that you're going to create an uneven magnetic field, okay, and you're going to send the silver atoms through. So if their orientation is plus minus, guess I could deal with this. So they're going to go through in some sort of way, like this, or like this, or like this, and like this. You're going to understand the faster they go, the less likely they are to turn, right? And the slower they go, the more likely they're going to turn into the magnetic field. So that's going to make a difference in how they fly. So when they turn to, in the magnetic field, then they're going to move in the field. So if they turn to the field, they're more likely to be moved this way or moved that way. So that's what's causing them to separate, is that they turn. And they're more likely and less likely to do that. And depending on how fast they're going, that's going to happen more often or less often. And that's basically the experiment. So when they increase the magnetic field, they start to create this separation. So the stronger the magnetic field, the fewer of them hit here in the middle, and the more hit in those two extremes. That is, the more of them are going this way, or the more of them are going that way. And that seems perfectly rational. And especially since the ones that are going slower are going to move really easily, and the ones going faster will be the last ones to go. But obviously, once I make the field strong enough, all of them are going to get moved, no matter how fast they're going, because the magnetic field is strong enough to turn them, even though it's not in the field very long. But that's all it is, and they call that electron spin. So instead of paying any attention to it's full atoms moving, polarized atoms, atoms that have a polar component flying through space, and they're pretending that they're being fair, to the experiment, by calling this an electron spin experiment. It doesn't make any sense at all. There's no, there's nothing, you're not detecting electrons in the experiment. You're not manipulating electrons. You're manipulating a whole atom. That's how bad the physics is. That every single experiment is ill-described, unfairly, unreasonably, inaccurately, poorly described. Just like the double slit. Again, it's such a simple experiment, and they've turned it into this wooey, complicated thing when the math is screaming to you the truth. I mean, if you really analyze, again, like I said, that if you really start analyzing the math is dependent on, and especially in the case of the, the thing that really just gives it away, right, is in the double slit. Because if you actually have a double slit with open slits, that is real-sized slits, real-sized openings, you do get the complex pattern. And the fact is that this 4 surface math perfectly explains that pattern. So if I understand that it's the only places I'm going to get a dot is when all 4 surfaces are in phase. That's it. All 4. So this is going to be basically this distance is creating all of these little dots. And this smaller distance between the other 2 surfaces is creating these bigger places. So this is where 2 of the surfaces are putting light here. And if the other 2 make a contribution, then it's double bright, or 4 times as bright is how it turns out. And so this is never, there's a dot here, but it's only from 2 sources. These 2 sources do make a dot here, but it's faint because it doesn't have the contribution of the other 2 sources. It's not in phase with the other 2 surfaces. And so that math works perfect. And that's the only, and that's The fact that that math does work using all four surfaces is the real way to do the experiment. So that would mean you have to have four waves. Nobody talks about it being the four-wave experiment, right? Nobody does that because they know it's not. And so that's the biggest giveaway right there. The fact that this math is guaranteed to get you the right answer. If you use these surfaces, you're guaranteed to get the right prediction. Because you're not using some cheat where, oh, I eliminated two of the surfaces by making them so close and I'm just really going to do a double slit experiment. You'll only get the right mathematical solution to two open slits in the double slit with photons using all four sources. That's the only way you get the right answer. All four surfaces. So whatever number of surfaces you have to draw these lines from all four of those surfaces and recognize that, you know, the reason why, like, say if I have 7 slits, I'll end up with dots, and they'll be separated by a distance, and that distance is representing the fact that you only have all of these sources, all 14 surfaces. All 14 surfaces only all add up there in that one location. That's when they're all at the same phase. Is just that location. So that's why they're so separated, is because it's only in those locations where all 14 are sending a contribution. And it works perfect. It makes perfect sense. And yet I have to do this over and over. Let's see. Pressure differential supports a push universe model. It boggles my mind that people make a mistake of referring to gravity as a pulling force instead of a pushing one. Why, yeah, I mean, obviously, it's because how would you do elemental pull? I mean, that should be the giveaway right away, right? What is a fucking elemental pull? How the hell do I elementally pull on something? You know, even if there was an ether, you know, even if I was in a pond and I had to pull the water, you know, obviously I'm pushing on the water, you know, how do I, there's no elemental pull. It's just a silly idea. So why are they saying it over and over again? It's not a mechanical concept. Just as an elemental wave isn't a mechanical concept. It isn't a mechanical possibility. You can't describe an elemental wave. You can't make an elemental wave. You need structure to make a wave. You need a medium to make a wave. And so the push-averse thing is just, you know, I didn't realize that that's what I should have been pushing 10 years ago. But yeah, that's what the point is. It's just so obvious that, oh yeah, of course. It's a collision averse. I mean, I could say push in a lot of ways, right? It's an impact averse. It's a smash into things verse. It's a, you know, but yes, that's the only thing there is. You have to have an interaction. You have to crash into something for you to have an interaction with it. There's no other way to have an interaction. I have to throw photons at the camera, right? I have to let the photons have to hit me. I have to throw them at you through the little hole in the fucking camera. All right, and then you get hit by my photons, right? The ones that sort of bounced off me, right? And then they went into the wire, and then the screen is reproducing them, and it's pushing them onto you, and then you're getting impacted by my little photons, you know. But they're not my, yeah, and obviously they're not my photons anymore. They're just recreations of the same message. But yeah, of course, that's how it's working. I'm pushing on you with both sound and pixels of little photon bullshit. I'm throwing shit at you. And the shit has information value. Ugh. So, anyway. Yeah, 14. Well, it's 11 now. So yeah, I lost 3 viewers. You shouldn't have told them how many there were in here. They felt crowded. So we're back to a more average number. But maybe I'll call it a video. I am still Struggling to feel normal. Stupid nicotine thing. You know, it's doable. I mean, you can sort of live with it, but I don't want to live this way the rest of my life, so I'm just hoping it gets better than this. I just don't feel like myself at all. You feel like you're living on top of a mountain or something and the air is too thin. You know, I'm not getting enough oxygen. Yeah, something like that. Alright, so anyway, yeah, I probably have beaten it all to death. So, whatever guy, 006, whatever, blah, blah, blah. If you want to email me or something, and like I said, if you want to ask me some questions or something else, I can always make you a private video, unlisted video, or something like that, and explain whatever it is you like explained, and such. You know, I could give you the HTML. I mean, you know, the guy's really got it. I mean, it's you know, but yeah, trying to do work with somebody else's code might be really difficult. Yeah, I just wish I could do it, but I just can't. I just can't do the learning curve thing. I'm just too damn tired. Trying to. It takes too much time, I guess. I was never. I don't know. It's like some things I could learn quick, and some things it just takes time to learn. I don't know what that is, but, you know. 15 days does seem a long time. You know, you got to stay away from people this time of year. So they're just covered with little germs. That's the only good thing of me and having my anxiety disorder. You know, I used to get like bronchitis terrible every year, all kinds of things, and then when I became isolated from the world, I was spared all of that horror. Tried emailing about something important but didn't get a response. Oh, well, I don't know. I mean, I don't know whether you're saying it's important or not, but there's some stuff I guess can't talk about at this time, and so there's some emails, if they're phrased the wrong way, I'm not responding to. But whatever, I don't know exactly the circumstance. I tend to, you know, pay attention to my emails, but whatever. Something could get overlooked. And if you don't succeed, try again. You're not going to offend me if you spam me a little bit. I mean, you can send me 2 or 3, and if I don't finally respond, then you'll know I'm being an asshole. But if it's an email address that's listed on my videos, it should work, and I should get it. So, blah, 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 blah. Blah, blah. Okay, so, yeah. I shall call it a night. So, till the next time, and such, and so forth, and whatnot. Thank you for the participation, and sorry if I'm irritable, but I just am. I am really tired of everything. It's really hard. It's just having a bad year. Just nothing goes very well, and I'm getting old, and I'm sick of it all. And I'm living without nicotine, and it just it's all so bad. It's so bleak. Yeah, I'm just tired of feeling like shit. But anyway, I'll endeavor to persevere. And see you next time and such.